Okay, in this video, we're going to integrate to try and find these finite regions. Now, a finite region is like a little packet of space between the line and the axis, which is closed off on both sides. So it's like it's pinched between the line and the axis at 2 points, giving like a little bit of space here. So this would be my finite region in green. So let's have a look at this. Find the finite region between the curve and the equation y equals 4x squared minus 5x cubed and the x-axis. So the first thing we're going to do is we're actually going to plot this function and we're going to look for that finite region. So I can find the roots of this equation. I could just use my calculator, but we can just factorize out that x squared there. So that becomes x squared 4 minus 5x. So then we see that we have two solutions here. We're going to have a solution where x squared equals 0, so x equals 0. And we're also going to have a solution where 5x equals 4. I'm setting this second bracket here equal to 0, which means I can solve that for x equals 4/5. So I've got my two roots. I've got a root here, we'll label this 0, and I've got a root here, we'll label this 4/5. Now I know it's a negative cubic, so it's going to start somewhere up here, exit somewhere down here. The exact shape in the middle, I think it's best to look at a calculator. So here I've got this function plotted. So we've got this lovely little bumpity bump in the middle there. So this starts up there, it comes down, and it exits. So looking for my finite region is the region that is pinched between the line and the curve is going to be this region here. So this is my finite region. So we're going to use integration to find this finite region. So I'm going to actually, even though I'm going to set this up over here, so I'm going to look at finding this area. I know that an integral gives me this area. I'm looking for the highlighted blue area. So I'm going to integrate my function. So this area, or this finite region, is going to be the integral between 0 and 4/5 of my function, which is 4x squared minus 5x cubed. So I'm just going to evaluate this integral. So I'm going to say area equals, I'm going to put it in square brackets after the actual integration step. So I'm going to add 1 to that power, that becomes x cubed. 4/3 x cubed, I'm going to add 1 to this power, so that becomes x4, and then divide the coefficient by the new power, so that's minus 5/4 x to the 4. I've got my two limits, 0 and 4/5. And now I can just find this integral. So I've got my two brackets here. So my first bracket, x takes on the value of this upper limit, so x will take on the value of 4/5. In the second bracket, x will take on the value of the lower limit, which is 0. So in this first case, that's going to be 4/3 times by 4/5 cubed minus 5/4 times 4/5 to the power 4. And the second bracket, x takes on the value 0, so that's 4/3 times 0 cubed. I know this is all going to be 0. 5/4 times 0 to the power 4. So this second bracket becomes 0. So let's just jump in with the old calculator and evaluate this one. So we've got 4/3 times 4/5 cubed. So we've got, let's go home, calculate. So we've got 4/3 times by 4/5, oops, don't need that, cubarinoed, and all of that is having what added to it? Let's go back to this. Oh, minus 5/4 times 4/5 to the power 4. 5/4, that's a minus 5/4 multiplies 4/5 to the power of, short-term memory is not my thing, to the power of 4. To the power of 4, x cubed. So we have it, it's basically 0.17. So this area, this finite area is 0.17. Generally good to stay in fractions until the final moment. But